Hi, welcome to my tour of mathematics for microeconomics. This clip is going to deal with one of the more knotty questions from my favourite book in the world, which is the Jakers Maths for Economics book. Now, this question asks quite a few things of us and isn't necessarily clear what it wants. So let's start to unpack the question. We're given the demand function of a monopolist. I'm asked to write down expressions in terms of Q for total revenue and marginal revenue. That's a good place to start. However, as the equation is written, P plus Q equal 100, this doesn't necessarily work for me. So I need to rearrange that, and it would be normal and good practice for me to rearrange that to make Q the subject so that I have an inversed demand curve. So let's subtract Q from both sides. That will give me P is equal to 100, take away Q. Now I have an efficient demand function. With the demand function, I'm now able to play on a certain trick because I know that total revenue is equal to price times quantity. I know that price is equal to 100 less Q. So if I multiply that by Q, I get total revenue. The total revenue is equal to 100 less Q multiplied by Q. So what's in the brackets is price. I multiply it again by Q. That will solve to give me total revenue. This I can do without too much stress. Total revenue is equal to everything inside the bracket times by everything outside. 100 times Q is 100Q. Take away negative Q, multiply through by Q. Positive and negative is negative. Q times Q is Q square. So take away Q power 2. Now I have a function in terms of Q for total revenue. Done. My next job should be to deal with the marginal revenue. Now, I know that if I have a total cost function, be it of cost or revenue, if I take the first derivative, I'll then get the marginal function, or I'll get the rate of change. So in this case, I'm going to work on the principle that I know total cost, and from this I can derive marginal cost. So I need to now remember the rule for differentiation. The rule is that when I do the change in total revenue with respect to Q, what happens is that Q to the power of n becomes nq to the power of n minus 1. That's the differentiation rule. So I times by the power, then I reduce the power by 1. This makes probably more sense if we actually write it out. So I'm going to move the board up a wee bit. So now total revenue has to become marginal revenue. So marginal revenue is equal to the change in total revenue all over the change in Q. This is going to give me 100Q. I times 100 by the power. 100 times 1 is itself. And I subtract 1 from the power. So this is actually 100Q to the 1. If I subtract 1 from 1, it becomes 0. Anything to the power of 0 is 1. So 1 times 100 is 100. This term has been differentiated. Negative 2Q. I times through by the power. So negative Q times 2 will be negative 2Q. That power of 2, I subtract 1 from it. That gives me 2q to the power 1. So I just leave that as it is. I now have my marginal revenue function. There's a trick that you can be tempted to play with, and I'm not going to tell you what it is because it doesn't work every time. So I've now, let's go back to the question, dealt with total revenue, I've dealt with marginal revenue, they're expressed in terms of Q, so I've done exactly what it wanted. Now I need to work on expressing the graphs of these functions. Now, it's good for your subject knowledge to know how to graph these, although if you're one of my students, I probably wouldn't bother to ask this on an exam. That said, this will probably go on YouTube, so just in case someone's got a cruel and sadistic lecturer, all my students would laugh. Okay, so I want to start by dealing with total revenue. I think I'll start there because it's the most exotic of the two. So I'll work in pink as I deal with this. Now, I know that this negative q square term is what's going to derive the shape of this. So I know that if something is square, it's parabola shaped, it's like that. If it has a negative sign ahead of it, I know that it'll be upside down. So I know that it's going to be that sort of shape, which tells me that it will have 2 real roots. In the instance that I know something has 2 real roots and follows a quadratic shape, I know I need to refresh my memory of the quadratic formula. Now, when I was at school, and hopefully this hasn't changed too much, the quadratic formula was equal to minus b plus minus square root b square less 4ac all over 2a. And you're given this where a is the coefficient of the square term, b is the coefficient of the linear term, c is the constant. So in the case over here where I have total revenue, the coefficient of the linear term was 100. The coefficient of the square term is -1. Now there's a trap for the unwary. There is no constant term in this. So c is equal to 0. And I know I haven't turned the camera on, but I'm dancing on the ceiling to know that c is equal to 0, because it means this -4ac element cancels out to 0. That's an added bonus, because if I have square root b square, the square term cross cancels with the root. So I'm left with the root being equal to -b plus minus b all over 2a. This is rather pleasant for me to deal with. So let's now use that revised quadratic equation to solve for the 2 roots of the total revenue function. So minus b is equal to -100. -100, we'll do it the first time with the plus. 100, b is 100. Now at this point, I don't need to go any further because I can tell you the answer is 0 without even touching the calculator. That's quite normal. The lower logical bound for total revenue is actually 0. So that's exactly what I expected. Fantastic. Now I do it again with the negative sign. Minus b is -100. Take away 100 all over. Let's just simplify it to -2. That gives me -200 all over -2. Signs the same will give me a positive, so that's equal to 100. Again, no calculator required. Life is good. I now know the two real roots, I know from just looking at the total revenue function, so I'm looking at this, I know that it'll be straight up, straight down. There's no skew. So I know the turning point will be where Q is equal to halfway between 100 and 0. 50, the turning point is 50. Now I have very good approximation and appreciation of how this is going to look. So now is maybe a good time to start sketching this, and let's move the board up a little bit, maybe just there. That gives me enough space to start drawing this. Now, this newfangled whiteboard is very, very good for drawing. Get the pen on. Let's get that nice and horizontal. That ought to do it. So total revenue on Y, Q on X. I think I did some of the working in pink, so I'll go back to pink. I know it's an upside down parabola shape. Since I'm just sketching, I'm going to invoke the not to scale get out of jail free card. Now I do know I need to go through the origin, which is there. I drew it quite steep, a little tail, maybe something like that. It's not too neat, but it's good enough for jazz. There's 0. The other real root was 100. Now, the top of the bell should be roughly at 50. And I'm very glad I invoked the not to scale argument before I started drawing. That way I don't look too silly. So pink is going to be the total revenue. It goes up, it goes down. That's very expectable. Now, I need to now work on graphing the marginal revenue. Now, the marginal revenue is a little bit easier for me to work on. So on the y-axis, I'm going to say I also plot marginal revenue, and I think maybe I'll work in a different colour. That blue might be quite a good one to go for. Now, I know from the negative 2q that this is going to be a straight line. I know it's downward sloping. I know it's going to cross the y-axis at 100. If it crosses the y-axis at 100 and has a slope of negative 2, I know I should cross the x-axis at 50. So again, if I've invoked the not to scale argument, I can maybe say that 100 is there and I need to get it to pass through 50. And because I've got something that's linear, I can actually just do this job with a ruler, providing I put the ruler in the right place. Maybe that. Let's try that. And I know it's a straight line, so let's give it a whirl. Take the ruler off, and that blue will be marginal revenue. So let's zoom out and see where we are in terms of answering the question. That's a nice place to leave it. So I've been asked to sketch the graphs and I've done it, so I'm up to there. The next part is asking me, find the value of Q, which gives a marginal revenue of 0, and comment on the significance of this value. Well, actually, I don't need to do anything further because I've actually managed to work out where marginal revenue is equal to Q. And if you look at the diagram we drew, we know that marginal revenue is extinguished such that Q is equal to 50. Now, I can probably say I've answered the question here because I've actually drawn a diagram, but I'll give a bonus piece of working, and I'll give you the bonus because you might not always draw the diagram. If I say that I want marginal revenue to be equal to 0, I could say 0 is equal to 100 less 2Q, and I can start solving down for a value of Q. So let's bring Q over to the left-hand side, make it positive. 2Q becomes equal to 100, so Q must be equal to 50. And without too much sweat, I've solved that with two very different methods. Now, at this point, I take one last glance just to make sure I have actually solved the question. I think I have done it. So there's quite a lot in this, and for some of my own students, two of the key skills that I often bash on about is the ability to solve quadratics for roots and the ability to differentiate, to find marginal functions. So this question for me is brilliant because it has two elements in it which I'm very, very interested in. And on that note, I've talked for long enough. So let's leave it there. I would advise anyone who is watching this, rewind the video back to the beginning, try and solve it yourself and resist the temptation to look at the answer until you have produced your own solution. Once you've got a solution you're happy with, see if it matches what I've done. And if necessary, watch again until you understand what I've done.